This is the Math 1111 Zoom meeting for Monday, November 2nd, 12 o'clock p.m. And so our assignments for this week, November 2nd to November 6th, we're going to do sections 4.1 and 4.2. And in section 4.1, we have page 372, practice problems 7 to 19 odd, 27 to 39 odd, and 55 to 59 odd. And in section 4.2, we've got problem 3, and then we jump down to some problems toward the back. We'll have quiz 9 on Friday to Sunday will be based on these problems. And from WebAssign, personal study plan, section 4.1, problems 1, 2, 3, 4, 5, and 8 only. Section 4.2, problems 1, 3, 4, 5, 6, 7, 8, 9 only. And just email me the percent of these 14 problems that you get correct. There should be 14 problems there. All right. I think you'll find chapter 4, comparison to chapter 3, a bit more straightforward. Most of my classes have. There's a lot more calculated work in chapter 4. Chapter 4, we start with exponential functions. Okay, and they give you the first one there. Through chapter 3, we've done polynomials. That would be x squared. So your base is variable. Your power is a whole number. Exponential functions reverse it. So their first example they give you is f of x 2 raised to the x power. So your base is a number, and it doesn't have to be a whole number. In the word problems, they'll give you decimals and everything. But we start with something simple like whole numbers, and your power is variable. Okay, so I'll show you an example graph of this. X, and then y is 2 raised to the x power. And we'll kind of fill it in backward. Oh, golly, -1, 0, 1, 2, 3. The positive numbers are pretty straightforward. 2 to the 1, you just wrote that on, then wrong, it's 2 to the 0. Start with 2 to the 1, and everybody should know that's 2. 2 to the second power, 2 times 2, get 4. 2 to the third power, 2 times 2 times 2, 8. You can see going this direction, every y value is times 2 bigger than the previous one. At 4, you'd be at 16. 5, you'd be at 32. You're doubling your y value. For every unit forward, you're doubling your y value. 2 to the 0, I hope everybody remembers, is 1. Anything to the 0 power equals 1. All exponentials, this is common to all exponentials. Three to the 0 would be 1, 4 to the 0 would be 1. So it doesn't matter what the base is, 0 power, you're getting 1. Now, -1, remember, you have to remember how your fractions work. You can go that over 1, switch it down, and you get 1 over 2 to the 1 which is 1/2. 2 to the minus 2, no, this is getting really scrunched, would be 1/2 squared, 1/4. You see the pattern? 2 to the 1 is 2. 2 to a minus 1 is 1/2. 1 over this. 2 squared is 4. 2 to the minus 2 is 1 over this. 2 to the minus, golly, I'm an idiot, wrote minus 2 twice. Okay, 2 to the minus 3 would be 1/8. All right, we show you a graph of this. Start from the middle, 0, 1. That's your y-intercept, 2, 3, 4. If I get up to 8, 5, 6, 7, 8. Okay. 1 over, and you're up to 2. You've doubled your y. 2 over, and you're up to 4. Your y is value. This is called exponential growth. 3 over, and you're up to 8. And you're getting exponential growth. Okay, if you go 1 unit to the left, -1, your values decrease by a factor of 2 in this case, factor of that. So you're down to 1/2, half of what you were at the previous. -2, you're at half of that, 1/4. -3, you're at half of that, 1/8. And it will never touch the x-axis. Phone call here. Let me stop the share for the moment. Nobody else is here. Mr. Paul is here. Mr. Paul, when did you come in?
Just a couple minutes ago.
Oh, okay. Well, I'm just kind of doing a general introduction to the chapter 4 here. Let me get back to the camera. Do you have any questions?
None so far.
Okay. Do you want me to just key? I won't take the phone. I didn't know anybody was here. I was going to stop the recording, take the phone call. Otherwise, I guess you all would have heard my phone call with my appliance guy.
Don't.
Okay. I'll restart the camera and either keep going or answer any questions you have. Well, let's see. We are recording. Do you have anything personal you want to ask about? Do you want me to stop the recording for?
No, I'm good.
Okay. Let me restart the recording then, or I'm sorry, restart the camera. All right. Do you have anything you want to ask about, or you want me to just keep going?
Just keep going.
Okay. So what they're going to have you do, and this applies to all exponentials, about run out of room, all exponentials. They're going to want you to read off domain, and that's pretty simple. There's no fractions, there's no square roots. You can see it from the graph. It goes all the way to negative infinity and all the way up, all the way to positive infinity. It's just like polynomials. There's no problems with polynomials and there's no problems with exponentials. Now the range is a little trickier. The lowest y value here, technically it doesn't hit 0. So that's going to be a parenthesis, but it goes all the way close to it. Now, it's not always 0. It's the value of that horizontal. This is a horizontal asymptote. The horizontal asymptote is 1 unit below, I don't know if this is getting too much gibberish here, one unit below the y-intercept. And that range is going to start from there. Now, it could be flipped down and it might go from negative infinity up to it or something. You have to read this from the graph. You can't really remember. You can memorize the domain. That's beautiful about it, unless they give you a fraction of them or something, which they won't do at the beginning here. It might be later in the chapter, but straight exponential is real nice and easy. You can memorize it. All right. And then the horizontal asymptote is right there. One unit below the x-intercept, y-intercept, 1 unit below the y-intercept. Crammed a lot of stuff on. That's the basic idea about exponentials. I was going to jump to working some problems, and then at the very end, they bring in some applications dealing with money and bank accounts. Do you have any questions, or do you want to see some example problems? Mr. Paul, did you have any questions, or did you want to see some example problems?
No, I'm good.
Okay. Well, you look on the assignment, I'm starting with the section from 7 to 19. It looks like I've frozen. Put the assignment page back up. Gonna come back. Okay, it's trying. Oh, here we are. I can twist this a little better. Okay. So yeah, we're starting with 7 to 19. Just try a few out of each section here. So problem 7 is right here. And this is pretty straightforward. It's about basically plugging numbers into the x of power. All right, there's some of them you can do by hand. The first one, 4 to 1/2 power, hopefully you know that's the square root of 4. You can do 4 to -2 or so by hand if you were inclined. The other two are going to have to be punched. So we'll start with number 7. Most people find this pretty straightforward. Page 372, number 7. F of x is 4 to the x. They want 4 things. F, I'll really separate them out in parts. F of 1/2. F of a square root of 5. F of a -2. And then F of 0.3. Further down, okay. And this is pretty straightforward. These again are all the x values, and you're just putting them in for the x up here. So you'd have 4 raised to 1/2 power. If you remember your basic algebra, that's identical to a square root of 4, which is 2. You don't have to memorize that. You can raise it, but just be careful. 4, there's your exponent key. That'd be caret there is your exponent key, and make sure you put your 1/2 in parentheses. So you get a correct value. It gives you 2, the square root of 4. Notice what happens if you leave off the parentheses. To the 1 divided by 2. I'm guessing that's going to go 4 to the 1, which is 4 divided by, you're going to get the same answer for the wrong reason. But it's not the right reason. You're getting 4 to the 1 is 4, and divided by 2 is 2. But trust me, put your exponents in parentheses if you need to. 4 to a square root of 5. You'll have to just punch that out. 4 raised to a square root of 5. It'll catch up. Froze again. Enter. 22.1945. Put in parentheses if it's, a fraction, something like that. I just happen to chose one. You get the same answer either way, but that's unfortunate. But all right, 4 raised to a negative 2. If you remember what I just showed you about the graphs, you need to switch that down. 1 over 4 squared, which would be 1 over 16. Your calculator will give you the decimal for 1 over 16. 4 raised to a negative 2, 0.0625. And if you went 1 divided by 16, 0.0625. And finally, 4 raised to the 0.3. 1.5157. You don't have to put a 0.3, a single number in parentheses. All right, that's pretty straightforward. If we jump down to, say, 27, now they want those 3 things: domain, range, and asymptote. G of x, 2 to the x minus 3. They want a graph, domain, range, asymptote. Okay. They tell you to do this not by plotting points, but starting from graphs, which means they want you to use like 2 to the x, read the minus 3 is down 3. You don't have to do it that way. You can just use your calculator. So if we go to y equals and clear off 2, you find these formulas a lot simpler than the ones in chapter 3. Minus 3. Keep the same window. Graph. I hope you read that as taking 2 to the x and down 3. I'll try to compare them. Call that 1. Your 2 to the x I have on the other page, and it doesn't curl back up. It stays down. So there's a straight 2 to the x, and you're going to send this down 3. So down 3, there's 1, negative 1, and negative 2. It's going to wind up at negative 2, this point. Then this is at 0 for the asymptote. Well, that's going to go down 3. So at negative 3, you're going to have your horizontal asymptote, and it's going to approach there. Horizontal asymptote will be y equal negative 3. We're pretty much the same number here, because a straight 2 to the x has y asymptote of 0. All right, and then it's just going to curl up, kind of identical to that. Domain here is the easiest thing. If it'll catch up, you can again memorize it, negative infinity to infinity. It just wants to keep freezing. Here we are. All right, from the range, it's approaching negative 3. So we'll start with negative 3, going all the way up to infinity. But you're going to have a parentheses. And I've just written down the horizontal asymptote over here. It'll be y equal negative 3. Any questions about that? If you're still with me, Mr. Paul?
I am indeed.
Okay, any questions?
I'm with you.
Okay.
None at all.
Do you want to see anything else from that section? It goes down through 39. Some of them can get a little trickier than others.
Sure, let's do another one.
Okay. You want to pick one out? It's from 27 through 39.
38.
Did you say 38?
Mm-hmm.
All right. Formula 38 is 3 minus 10 to the x minus 1. Graph, make sure you put it 3 minus 10. You'll have an exponent key, parentheses, x minus 1. Got to put that x minus 1 in parentheses. I'll just do that first. Three minus 10 raised x minus 1. It'll catch up. I've got it all in, but it's not catching up. Not cooperating today. There we are. Hit the graph button. Okay. Kind of see how it's kind of flipped down because you've got this minus sign in front of the 10. Give us our best sketch. It looks like it's crossing at 3, the y-axis at 3. Actually, yeah, it kind of looks that way. It may not be actually. That's like these graphs are hard to do. Let's see. It's crossing the x-axis between 1 and 2. It may not be actually crossing at 3. It actually should be. This is kind of like shifted right 1 and you're up 3 off of an exponential. So your actual kind of y-intercept point kind of shifted. It's shifted like right 1. All right. And see at x equals 1, you're getting 10 to the 0 is 1. 3 minus 1 is 2. So yeah, your x-intercept kind of like at 2. And then it's going up toward 3. You can almost see this from the trace. See this trace button? We haven't used it much. You hit it. You can watch you're going there right at 3. 2.998, 9999. Okay. So that's going to be your horizontal asymptote is y equal 3. You're approaching that and you're coming down between this, you can see it's hitting between 1 and 2. And you're kind of dying. It'll catch up to me. It'll quit showing my hairy knuckles. And I've got another phone call. Okay. Not a smooth Zoom session today. Should I break the share? And yeah, it's going to break it for me. Can you still hear me?
Yep.
Okay. A lot of activity around my
Occasionally,
place.
though, your mic does cut.
That's cut, yeah. I'm trying to get the camera back. Not a smooth Zoom session today. Maybe 9 p.m. will go better tonight. Might be a lot of activity during the day. can't get the camera back at the moment. Okay. All right, seems to have come back. That's a weird picture because I haven't moved my, okay, here we are. All right, so you see this picture off of, see this graph off of this formula? Can you hear me?
Yes, I can indeed.
Okay, and so you see the graph?
Yep.
Okay. So domain is, again, really easy. Negative infinity to infinity. Now your range, so you're going to have to read this. Read this. Remember, it's y min, comma, y max. Well, this is going down to negative infinity. It'll catch up. And you're coming up and you're bending below 3. You're not getting above 3, but again, it does not touch 3. So, any questions about that? Your horizontal asymptote, already labeled it up here, is y equal 3. So a bit more of a puzzle on that one to try to puzzle that one out. You want to see problems from the next section?
Sure. Let's go with that.
In the next section, started it at 55.
Which problems?
Okay, from the assignment, the camera will show it. We're basically going to jump 55 to 59.
All right.
Okay. And if you look, they are about compound interest. They'll usually give you money invested into accounts, and then it's talking about this compounding. And then on this one, they want you to give you an interest rate. Notice they're not giving you the formulas. So let me show you the formula you need for that. Is working my camera all around. Right here. Compound interest. P is the principal you put in the bank. Principal right there. R is interest rate. N is the number of times you compound, and T is the years that you leave the money there. I don't know if you've seen this before. Pretty straightforward once you know where every number goes and what the letters are. Compound interest. P 1 plus R over N raised to the N times T. Again, P is print. They expect you to kind of know, when they say they're putting money in the bank, they expect you to know that's your principal. I don't know if you've taken out your own car loan yet, or a house loan, or anything, or a loan for anything, but you don't really have principal. Well, yeah, you have the principal that you owe when you take out a loan. They call that principal. Is money you put in there. But right now, we're just assuming you're going to put money in the bank. Okay, at R is your interest rate. T is the number of years. And N is your number of compounding periods. Okay, they generally will not tell you the N. You're supposed to divine it from, like, if you see the word annual, that is N equal 1, once a year, annually. Semi-annually, that would be N equal 2, twice a year. Quarterly, N equal 4, 4 times a year, 4 quarters in a year. Monthly, that would be 12 months in a year. Weekly, that would be 52 weeks in a year. These are pretty much straightforward plug and chug kind of problems. I don't think I'll fill in all of 55. Maybe we'll just do 1 or 2 of them. So if you go to 55, your principal is 5,000. Compounded monthly, so that would be N is 12. R is 4%, and we'll convert that to 0.04. So their table is time in years. Here's your amount. Okay, so it's in word problem form, and the numbers are kind of all spread out. They're having you run it for 1 year, 2 year, 3 year, 4 year, 5. I'll just do the first 2, maybe 3. Okay, so they're going 1, 2, 3, 4, 5, and 6. Please come back. I just wrote down 1, 2, 3, 4, 5, and 6. And dadgum. Okay, there we are. So basically, I barely see the formula. I'm plugging and chugging up into this. I'll just write it out on this row. Principal is 5,000. Parentheses 1 plus 0.04, and we're dividing that by 12. Dividing that by N. And we're raising that to the 12, N times T is 12 times 1 year. So in effect, 12. And it's just a matter of, you see, you start with 5,000, we're going to see how much more money. Compounding is when they stop, run through this formula, and add the money back into your account. So, plug and chug if it'll catch up to me. One plus 0.04 divided by 12. And it's raised to the 12. It'll catch up to me. Okay, here we are. Now, if you want to be really technical about it, that's times 1. Twelve times 1. Okay, so we hit enter. It'll give me the, I've got 5203.71, say. It's going to take its time showing you that. So in effect, you gain $203 in 1 year at 4% compounded monthly. There you are. Now, if you want to be really slick, since they just have only changed the T to 2, your next row, 5,000, 1 plus 0.04 divided by 12 raised to the 12 times 2, in effect 24th. If you really want to be really slick, you can go second enter. And all you got to do is run over to that 1 and make it a 2. Nothing else is different. If it'll show you that on the screen, there you are. You know about editing and calling stuff back? You ever seen that before?
Not sure. Think so.
All right. Well, I'll hit enter and get this answer. And when I want the third row, I'll call it back and change that 2 to a 3. And I don't have to punch the whole thing, you know, all at once every single time. I'm at 10,407. No, I'm not. I don't know if you noticed this. I've screwed it. There's no way it jumps from 5,000 to 10,000 in 1 year. You're not going to, it doesn't do that. I should have stuck that 12 times 2 in parentheses. So back up. I didn't use the parentheses on the 12 times 1, and I should have. Yeah, you're not going to get a zillionaire in 1 year. It's just, the real world doesn't work that way. I should put 12 times 2 in parentheses. Or you can do it in your head. On the next row, make it 36. This row, it's 24. 12 times 2 is 24. Yeah, that's much more realistic. 5415.71. It'll show you that. Yeah, there you are. You're not going to get to 10,000 in 1 year. Trust me. I've left money in the bank. I get letters on my money market. Congratulations, you earned $1 this month. I don't want to tell you how much I've got in it. It's an outrageous amount left over. So yeah, if I want the next one, I call it back and run that cursor over to that 2 and make it a 3. And now my power is 36 and I'm up to 5636.36. Do you need to see any more? Want to see the answers, filling in that table. That's pretty much it for 4-1. Do you want to see anything from 4-2? Let me just show you what's going on. 4-2, they use what is called continuous compounding. If you start with your A is P, 1 plus R over N raised to the NT, turns out this base will go to a number 2.71828, I believe, boom, 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 that they call E. And it's on the left side of your calculator, right here above this LN key. In fact, the rest of the chapter is pretty much about this E and LN key. If I want to see what that value is, second E raised to the 1. There you are, 2.71828. It goes forever, just like pi. It's such an important number, it has its own key, but it's just like pi has its own key, but it's a different number from pi, of course. Okay, they're trying to show you this in 4-2. I don't know if punching this out would explain any of the gibberish any better. Not, they call it the natural exponential, but they are, my page, let's see, they're trying to show you this is kind of the center by using $1 in 1 year, and they're trying to show you this when they raise the number of compoundings, you come up with this 2.718, if I can show you, yeah, 2.71828, and that's so important, it's called the natural exponential number, natural exponential function, and they use this letter E. But it's no real different than using 2 to the x or 3 to the x. In fact, if you graph 2 to the x, then e to the x, and then 3 to the x, this is like taking 2.71a blah, blah, blah to the x. Just try to give you some confidence in this. 2 raised to the x. Down with 3 raised to the x. I'll graph them both, and then I'll stick on E. You can see what I have graph. All right. You see 2 go up. Show 3. Note they have a common x-intercept. 3 pulls closer to the y-axis because it goes up quicker. Now I'm going to stick on E. Second, let's see, come down. E raised to the x. Okay, I don't know if you can see it go, yeah, right between them and closer to 3 than to 2, because at 2.718, you're closer to 3. I don't know if that gives you any more confidence in it. And they're just going to want the same kind of things. H3, are we losing anybody? Or do you have any questions about this? You want to say anything, or?
Sorry, your voice just cut out.
It's cutting out. Yeah, sorry about that.
Yeah.
Do you need to, you want to say anything or ask anything?
I think I'm good.
Okay. So number 3 is really similar here. This is the first homework problem, page 377. They give you an h of x as a straight e to the x. They want an h of 1, h of pi, h of a negative 3, and then h of a square root of 2. It's the same idea. You're just sticking, these are the x values, and you're just sticking them in, and you don't have to punch an exponent key. When you hit E, you get the exponent button, and you don't have to punch it separate. So this one is a straight E to the 1. I've already showed you that, but we'll punch it again. E to the 1, 2.71828. On the next one, e to the pi, second e, second pi. They both got their own keys. 23.14. In effect, you're taking 2.7 close to 3, raising it to the 3.14. So you're not quite 3, and you're a little over 3, you know, so you're just short of 20. Notice if you had 3 to the 3, you'd be at 27. But you're just short of 3, and you're a little over 3 there, so it ends up at 23. E to the negative 3. So you could punch that as 1 over e to the third if you wanted, but we can do it straight as second e negative 3. 0.049787. And an e to a square root of 2. It's all about calculator punching. Pretty much this whole chapter, with the exception of the logs. There's some algebra in that. It was e to the square root of 2, my fault. Square root of 2. 4.113. But a lot of the chapter is a lot of calculator punching. You find this easier than chapter 3?
A lot easier.
Okay. And then all we really ask for, again, if you look at the assignments, is just some of these word problems, these kind of problems toward the end, starting at 23, are kind of like word problems where they give you formulas with E. Some of them have a lot of parts, like 25's got a lot of parts, 23 does not. And it's pretty much, most of them work out by plugging and chugging. You want to see an example of one of those? Or have we shown you enough today? I can try 23. They're saying D of T, this is a dosage of a certain drug. 50 e to the negative 0.2 t. So they're giving out a certain medical drug. Number of milligrams remaining in the bloodstream is modeled by this. How many milligrams after 3 hours? So you give the patient the drug, and how much of the drug is in there after 3 hours? In effect, they want you to find D of 3. 50 e to the negative 0.2 times 3. Just be careful with this and make sure that you stick this all in parentheses. So you might punch it 50, parentheses, negative 0.2 times 3. E, negative 0.2 times 3. Looks like it's 27 milligrams left. 0.44, is it milligrams or grams? Probably milligrams. Yeah, milligrams. You don't have to know that. And this is not science class. We're not big on units. But there's that many milligrams left after 3 hours. I think the point being that there's that much left in the bloodstream and the rest of it's been absorbed, presumably to tackle whatever medical problem this patient had. We're at 46 minutes, I guess. Do you want to see anything else? Ask any more questions? Or do you think this is good enough? It's pretty much an intro
Should be good
to,
enough.
think it's good enough?
Yep.
Well, it's pretty much an intro to 4.1 and 4.2.
All right.
Appreciate you coming out today.
Thank you very much for having me.
Sure thing. Thank you. And I guess we'll have another Zoom meeting at 9 o'clock tonight
All right.
for anybody who wants to come out. All right. Well, thank you very much. And we'll end the meeting.
All right. Bye.
Mhm.